webinar. We are going to have 4 series. They are each going to have different topics. So please come and join us again at the end of this series. Today, I will give you the dates on the next upcoming series webinars. Thanks for joining us today. Hopefully you have your lunch and you're kicking back and you're ready to sit down and learn a little bit about heat trace. We have just a 30-minute segment. This is not meant to be highly technical. This is meant to give you kind of estimating tips and things to look for in the specifications and drawings and things like that. And we will be taking questions along the way. Depending on our time frame, we may or may not be able to answer all of the questions today. But on the right-hand side of your screen, you will see a red square that has 3 dots. If you click on that, you will see, or it may already be open for you, you'll see a chat button. Under the chat button, feel free to send us a message. You can do a chat mode. You could also change that chat mode to a question mode, and we will certainly answer any questions. As I said, if we don't get to them today, we will make sure we get to them in the near future through an email. All right, without further ado, let's get started. So today what we're going to be going into further is how to get started on heat trace selection. There are industrial, commercial applications and some basic things that you should be looking for, and we'll go through some of those tips. Estimating. For those estimators on the call today, hopefully I can give you a few points to get you in the right direction and help you make your job easier. And then lastly, we'll navigate through the spec sections and what you might see or you may not see, and things to consider as you're putting a bid together. So for introductions, my name is Melissa Melton. I have been with the Dale Prentice Company for over 25 years. I've been doing mostly design work throughout my experience here in the inside sales and then product management for a time frame. And then most recently in an outside capacity where I've been doing sales engineering and field technical services for the last 9 years. And of course, that's me with a very nice looking salmon. So just wanted to share a nice picture of a good looking fish. Who we are, Dale Prentice Company. Dale Prentice Company has been around for a long time. We are a Michigan-based company. So that's important to know that we are here. We're not just a .com. We are here to support you. And for the most part, you know, we focus on a lot of our products in the safety world. Some of the products that we represent. Today, I'm going to be talking mostly about the electric heat tracing. So you obviously know we do pipe heat tracing. We also do other types of heat tracing, which I'm not going to get into today. That will actually be in the segment series number 2, where we'll go into further applications. So snow and ice solutions and various other ones. Leak detection systems is another specialty product that we offer through TraceTech, which is also an nVent or a Raychem company. Gas detection systems, as well as some other specialty systems we have with our engineering department. For those mechanical contractors on the phone, for those that don't know, Dale Prentice Company offers an array of solutions in the industrial and commercial world for valve automation, explosion suppression, overpressure protection in terms of relief valves, rupture discs, as I said, explosion suppression systems. So if you have any of those types of applications on your next project, please feel free to give us a call and we will get the product expert on board to make sure we get it designed properly. Okay, what is heat trace? So this is Deshaun Grigsby. He's one of our my partners down in the Southeast Michigan office. He is a technical sales engineer like I am, and he has done a 6-part series on it's available through our website. If you go to the www.prentisco.com, you can feel free to browse through those 6 different series. He goes through some pretty basic introductions on what heat trace is, what self-regulating heat trace is versus constant contacts. He goes into the parts and pieces, what the components look like. For those who can't hear me, you may need to reconnect. I just got a notification that you're not able to hear me. So please reconnect if that's the issue. I will type it out in the message as well. Okay. So like I said, Deshaun Grigsby, it has a 6-part series. If you'll feel free to go on to the website and you can hear more on that. So today, we're going to talk really the basics on what heat tracing is and how you guys can look at a project and be a little bit more knowledgeable on what you need to get started. So the basics is you're putting an electric cable on a pipe. In this application, that pipe might be for freeze protection. That pipe, it also might be for flow maintenance. So depending on what you're looking at, those are the 2 things to consider. With every heat trace application, what you're really trying to do is drive more heat into the pipe than what is being lost through the insulation factor. There's a lot of things that go into those calculations. So things that you need to think about, pipe size is a really big one. The smaller the pipe diameter, the less heat losses you have, the larger, more surface area, more heat losses you have. So if you come to me and say, I have a 2-inch pipe, I might say, okay, yeah, we can put a 5-watt cable on there. But if you have a 10-inch pipe, it might end up being a 12-watt cable. So please be aware pipe size is a big factor. Pipe type as well, so whether it's plastic or metal, and I'll talk a little bit more about that. The temperature difference. So in most applications, if we're talking about freeze protection, we're really talking about what is our minimum outside air temperature going to be versus keeping it above freezing. In most of our design applications, we have a 40-degree Fahrenheit maintain temperature that we like to design to. Although please check your specifications if it's a project that's been engineered. They will call out in some cases the design criteria, and that is important if we're in an area that maybe is a little bit warmer, or if we're in a climate that's colder, there may be a deviation on what their minimums and maintain temperatures are. Insulation thickness and type, both of those are very, very important. This is probably one of the hardest things for me to collect in a project in the upfront. If I'm talking to a mechanical or plumbing contractor, it becomes a little bit easier because they're obviously a little bit more knowledgeable on what's designed on the project. If we're talking to electric contractors, it's a little bit more of a challenge to go through that design information and figure that out. But that is a very important factor that will change how much heat loss and how much watts per foot needs to be put into that pipe. So here's how you get started. First, you have to look at what is your application. We are going to be talking mostly about pipe today, but if your application is a gutter application, obviously I have a completely different product line offering for that type of solution. If you're talking about a surface like a sidewalk or a truck ramp, something like that where you want to keep the concrete from snow and ice, that's a completely different application. So that's first and foremost what you need to look at. What are they trying to achieve with this heat trace? The second thing with the application is very, very important is this in an industrial environment or is this a commercial environment? We, a lot of times people come to us and they don't give us all the information. We may quote a product that is, yes, it's UL approved and it's compliant for a lot of different areas, but it may not be approved for a hazardous location as an example. So if you have an industrial application, it's really critical that you know that. And also if it's a hazardous location, it's really important to understand what the area classifications in that area might be. A Class 1 Division 2 area, as an example, is what we handle all the time with our industrial components, standardly rated for. But if you get into an explosion-proof area, Class 1 Division 1 area, that becomes a completely different product offering that's rated for that application. Next, really just the basics. I've talked about a lot of these already. The pipe size, the pipe type. And what I mean by type is if you have a stainless steel pipe versus a PVC pipe, that self-regulating heat trace will actually act differently on that type of pipe. And thermally, it doesn't promote the heat trace to increase its output as well if it's on a PVC pipe. So those are things to consider. If you came to me and you said, hey, I have a 4-inch pipe, but you don't know what type it is, and I design it based off of a steel or stainless steel pipe, and then you come back to me, a couple weeks later and say, oh, I found out it's really a plastic pipe, that may change the value. Instead of being a 5-watt cable, it may bump it up to an 8-watt cable or even a 10-watt cable. So it really is an important item to take note of. The length, obviously, and when I talk about length, I'll get into a few tips here in a minute. I'm not just talking about when you're looking at a flat piece of paper, what the pipe length is. There's a few more things that need to be thought about. Insulation type and thickness, as I said, obviously the thickness is a big factor, but the type really becomes important too, because if you have a fiberglass insulation, the value of that R factor is going to be much different than if it's a cell glass or a different type of insulation. They have different properties and how they hold that thermal temperature in. So those we do need to take into account. And then, of course, finally, the electrical details, right? We need to know the voltage. Ironically, this is probably the #1 thing that gets forgotten in terms of people call me and ask me for a quote, and they'll give me pipe information and yada, yada, but then they forget to tell me, oh, yeah, what voltage do we have available? So that is an important piece. And then controls, and I won't go into too many details on controls, but we have options out there. So sometimes it's called out in the specifications, sometimes it's very vague. So we have thermostat type controls, we have more sophisticated electronic controllers that will provide things like monitoring and ground fault and alarming. So those are the details that you want to get in front of. If you're going to send us an email, you want to collect this information, and this will be enough for us to move forward on that. What are the parts of heat trace systems? All right, so let's break it down. For those people who don't know, of course, you need a power source, right? That power source comes from a distribution panel. Our systems are hardwire systems, and by that I mean we do not have a heat trace that has a component that plugs into the wall. That is more of a residential grade product. That's not something that we typically would be putting into a commercial or an industrial environment. In between the controller, the power source, is a controller. Again, that could be an electronic controller with an RTD sensor. It could be a thermostat. Do you need to have a controller? I get this question quite often. With self-regulating cable, the black and white answer is no, you do not. However, things to consider for your client and the specifications. Without a controller, you have no way of completely turning off that heat trace. So even though it does self-regulate, if someone forgets to turn off that breaker in the springtime, it will continue to produce a minimal amount of heat throughout the summer months. And so it's really just an energy efficiency thing, and also life expectancy of the cables. So we do really encourage some type of control. And again, we have several types, so we can have that discussion on what the best is for your client. And then from the power wiring, we have to go into a transition piece. This particular diagram is showing the commercial side of our power connection kits. Our industrial versions look different, but it does essentially the same thing. So what we're looking to do is we're looking to make that conversion inside of this connection in a safe manner from your power source into an electric heating wire that will start heating as soon as it leaves this component. So being right on the pipe is the best place for power connection kits to go, or as close to that source as possible. From there, obviously, we have the heating cable. We have several types of heating cable, again, depending on if you're talking an industrial application or a commercial application. So if you do have any questions about that and what product offering is the best solution, please give us a call, because if we're talking about an industrial application, as an example, you may have a product offering that needs to be rated for, say, steam cleaning or higher temperature exposure. So we want to make sure you do get the right product offering for that application. Next, we have components. So self-regulating heat trace is a system that is field cuttable, spliceable, teeable. So we have a number of different options for you in the field. So if you have questions about, what we have to offer, T connections versus splices versus X's, we do have a design guide as well and an online tool source that can help along the way, but always feel free to call us and we can work you through that. In some cases, T connections aren't the right option. I will say that if you're looking at a diagram that shows a long pipe, and then you might have a short 5-foot T segment, and this is just a freeze protection application. Instead of putting an expensive T connection there, my design preference is really just to double the amount of heat trace cable that would go along that T and come back to your main and then continue on the pipe as you go. So again, as you're looking through diagrams, keep that in mind. If you don't need to have expensive Ts and man hours and everything else, that's always our preference, to look at the best solution. And then finally, wherever you're ending your pipe, you want to have a termination kit that is approved with the product. I have gone out to the field and I have found I get to the end of the cable and it is an electric electric tape that is tying this section down. That's not an appropriate or approved way of doing it. So we always need to have end seals. In both our industrial and our commercial, we offer a couple different variations, but one of the variations that's nice, it has a lighted end seal. And that light is simply an indication that this heat trace is powered, it's energized. And so for field maintenance, it's a very good visual for the guys to know as they walk down pipes that, yes, this heat trace is working appropriately, that I see the light is on. All right, so applications. Again, this is our commercial version, XL Trace. The same applies in our industrial processes as well. We can do freeze protection applications. These are some of the areas that you may see those applications. But again, in the next series, I will get into a little bit further. Flow maintenance. So anytime you're looking at maintaining a higher temperature, so greasy waste is an example. We like to design and maintain for 110 degrees versus freeze protection, which would just be at 40. So that makes a big difference on how many watts per foot is required. Another application I'm just going to point out, because it is a fairly new one that NFPA has recognized and approved, is a fire sprinkler protection. So while it is very similar in design of our other freeze protection applications, there are some specific requirements that NFPA calls out for fire sprinkler protection so that we can monitor things. So if you do have an application that is fire sprinkler, please be sure to note that, so we are ensuring that we give you the right controls for that. All right, so we can do both above ground piping and buried piping. The one key factor here is that the NEC code does require any connections be accessible. So whenever you have a buried pipe system, please keep in mind that all the connections need to come up out of the ground in an accessible way, whether it's on the beginning or at the end of the run. In some cases, it might make more sense to go down a pipe system that's buried and come right back to the power connections location. And in some cases, as this diagram shows, it's okay to come out at the end with the end seal in a box that's above ground. So both are acceptable, but those are things that need to be recognized. The other thing I'll point out is whenever you go below grade like this in a buried application, or for some specific product applications, like as an example, the greasy waste product, we do require the CT jacketing cable. We have a jacket cable that is water and non-organic rated. And then we have a product that is a fluoropolymer jacket that's a little bit tougher. It's chemically resistant and corrosion resistant. So that's very important also to think about when you have buried applications. All right, let's get into estimating tip number 1. Estimating tip number 1 is don't forget the extras. What do I mean by that? Well, I just talked to you about this buried pipe application, right? So whenever you are going underground, or for that matter, if you're talking about a pipe riser that might be on a building that you have to go up 4 floors, you want to take into consideration those verticals. That's something that's missed quite often. Give yourself that extra 5 feet to come up out of the ground. Give yourself the extra 30 feet that you need because it's a vertical piping and you don't want to miss that in your takeoffs. Other extras. This is a big one. Valves are more heat loss. So we do have to wrap our heat trace cable around those valves. In our installation guide, we do go through very specific steps in how this is done. And I will also share with you, if you hit your 3 dots on the tool on the right-hand side of your screen, I will be sharing a couple files with you right now. Feel free to download it as you want throughout this presentation. The first one is the commercial pipe heat trace request form. So it goes through some of those things that we just discussed on what you need in order for us or you to put together a complete design. The next one I'm sharing is basically a quick reference guide, and this is actually an industrial version of this reference guide, but it does highlight some good information whether this is a commercial or industrial application. On the second page, it does highlight some of the extras that you need. So as an example, you can look up a 4-inch valve and decide how much extra heat trace you should be adding into your estimate. The other big one that is missed a lot, this pipe is going underground, as you can see here. Anytime you have a pipe that goes underground, and it's most often called out in the specifications, so be on the lookout for that. But you want to take the heat trace and you want to go below grade, below frost line is what we like to say. My typical recommendation is 3 to 4 feet. And then you're going to turn back up on that pipe, and this is where your connection is going to be made. So don't forget about those extras. I mean, 4 feet down, 4 feet back up, that you've just added another 8 feet to your overall design now. The other extras that we want to make sure we're thinking about is any connections. For every connection, kit, end seal, T connection, we want to add an extra amount of footage. Depending on the application, you can be conservative or you can be extra, short with your number. I usually add about 5 feet per connection. That gives the guys a couple oopses in the field if they need it, as well as safety factor. All right, estimating tip number 2. Time is money. Hey, we know that, your estimations are important to get right. And if you're not taking into consideration how much time, how much man hour it's going to take for every connection, and you're just basing your man hours on this isn't the amount of linear footage that I have, then you may be cutting yourself short. So I like to recommend a minimum of 30 to 45 minutes per connection. And that includes the power connection kit, NETs, as well as your end seal. Your end seal is a pretty quick, easy installation. So is it going to take 30 to 45 minutes? No, of course not. And as your guys get more experienced, is it going to take them 30 to 45 minutes per every connection? No, of course not. But this is what I recommend as a very minimum value to make sure you're not, so that you're covered in your estimate. The next thing is the extras that we just talked about. Don't forget to include those in your per foot man hour price for labor. It's going to take those guys extra time to wrap around that valve. It's going to take them extra time to go down underground and come back up. So make sure you are taking that into account when you're adjusting for your man hour costs. And then power wiring, of course, if you're an electrical contractor, that is. If you're a mechanical or plumbing contractor on the phone right now, then you don't need to worry about this cost so much, right? But the other thing is the controls. And here's a bonus tip. So there's going to be a requirement per NEC that you have to have a 30 milliamp ground fault protection. This is one of the number one things that gets missed in the field. Sometimes it's called out in the spec. Sometimes it's called out in the panel schedule. Sometimes it's missed altogether. It's something for you to be aware of. You can have a 30 milliamp ground fault equipment protection style breaker, or you can have the controller itself have a ground fault protection included in it. So be sure to think about that. And if you have any questions, be sure to ask us and we can get you through that. All right, estimating tip number 3, who can you rely on for help? So of course, we hope that you rely on us, but in any company out there that does any design assistance takeoff, make sure they're doing the right job for you, giving you a complete quotation. And then of course, as I had stated, we are a Michigan-based company. We do provide field support as needed. So we're here to assist you for the full measure of the project, not just in the beginning. All right, estimating tip number 4. All right, so who is responsible for purchasing this? Who's responsible for the installation or the wiring of this? There's a lot of parts and pieces and components to this heat trace system. And you have to be cognizant of where it's called out for in the spec, where, what their notes say in a project that's a designed project. So be sure to ask those questions. And if you're ever uncertain about it, you can call us and ask us. Maybe we've already heard from the engineer or heard from a contractor that we've gotten the answer. Otherwise, it should be done as a RFI back to the project management team. All right, spec sections. So plumbing section it used to be in the 15 numbers. That has now changed. So it's now the 220533. You could also see it in the 230533. I've also seen it under this plumbing section code number. So unfortunately, there's not one place to look, but these are 4 options that I've seen quite often in the plumbing section. If it's in the electrical section, This is the older version, but this is typically where I see it in the electrical CSI specification section. There are some variations to this, but for the most part, it's 260533. However, we didn't talk about a lot of these things, but roof and gutter applications, as an example, may be in a different section. So you need to be aware of it because it may be called out on the mechanical print or on the electrical print. But the specifications may be found in the 07 sections. And then finally, if you're in an industrial application, process piping may also be under the 400-533 section. Okay, so just some really quick things, what to look for in a spec section. This is one example of a spec section number that you might find it in. This would be in a plumbing pipe section. Some of the big things to look for is make sure you're looking at all of the details that they are calling out. In some cases, it's very, very vague. They don't give you a lot of product information. And in some cases, it gives you capacities. It gives you characteristics. So in this particular project, they're looking for a 5-watt cable. They're looking for 120 volts. So as you go through those details, make sure you're keeping track of those types of notes. Some specifications are very, very general. I'm just going to warn you that there are a lot of master spec engineers out there that they grab on a bunch of applications, a bunch of information that may not pertain to your project. So this one, as an example, called out for snow and ice melting for roof and gutters. It also called out for a domestic hot water maintenance type cable. In this particular project, there was no domestic hot water cable in the drawings. It was just a roof and gutter. So just be cognizant that there may be more information in the specifications that is actually relevant to your project. Some projects give you an actual schedule. So they might give you specific pipe data. They might give you specific information. Sometimes they'll call out even a specific part number or wattage. So those are the things that you want to take a look at and make sure that you're providing to us to give you a complete quotation. Lastly, I want to make sure everyone is looking at warranty. Warranty for most products in our environment, in most projects, are maybe 1 to 2. Some engineers are enforcing that they get the really good warranty. So make sure you're paying attention to that. We offer the 10-year limited warranties with our nVent Raychem products. And if it's called out for that, make sure that you are providing that information. All right, so now if your specifications are lacking or there is no specifications, where do you go? So in your drawings, you're going to see keynotes. Keynotes are probably the #1 place that I will find the information. Sometimes it's called out in the enlarged electrical rooms where you might have some more details. So on this particular one, it was actually calling out what model controller they wanted. So those types of notes are very important to keep track of. The panel board schedule for the electrical contractors, this is a no-brainer. You guys are always looking at these schedules. Sometimes engineers do a great job of putting out and highlighting where they're putting their electrical connections for heat trace. However, in most applications, most instances, I find this is missed. And it's definitely missed to call out for a ground fault breaker. So those are, again, things that you have to keep track of on every project. All right. Hey, sorry, I've gone over a couple minutes, guys. I want to let you know that you are invited to join us for the next 3 parts in the series. The next one is going to be on application solutions, where you can sell or how you can upsell your services. So if you're a project manager or a design estimator or a service guy that you just go out to the field, this is a good one for you to know when you walk up to a building, where are problems? What solutions do you have? And we'll talk about those and how we can help you further. All right, I hope you had a great lunch break, guys. I appreciate your time. And that's my information at the bottom. If you have any questions, feel free to either through the chat box or through an email, give us an email and we will respond to any questions there might be. And thank you very much. Talk to you later.